Oh my gosh, it is 2:03 UTC. Where does the time go? Where does the time go? Hey, everybody, this is Cosmic, and you are tuned in again to another daily live stream called Astronomy Daily Live. Now, I have absolutely no hydrogen hydroxide whatsoever. I have absolutely no coffee. I have nothing. I have nothing. I am totally unprepared. I am going to tweet that I'm live. Okay, yay, I did that. But I've been been a little distracted here for the last hour or so. I was listening to Gilles' shortwave show earlier today, and I'm going to pull up my chat here too. Um, and he's really nice enough to sort of, when he sees me on the chat, he does a big shout out, and I know um, um, several people who are watching this live and later are actually over from his channel or channels, and so yeah, I'm glad you're over here. You like astronomy too? Hey, I come on into the circle of friends. It's just a casual get together every single day at 2 hours UTC, where we turn off the TV, we turn off the news, and we think about the universe and we think about our place in it. And you know, for me, I just sort of stand in absolute awe, right? It's like, wow, this is very cool. Yeah, this is very cool. So, cheers. Glad everybody's here live at 2:05 UTC. All right, very cool. So, yeah, I did get up early this morning to see if I could see the InSight launch. This is the latest Mars probe. It's going to be a lander. It's going to be hopefully in about 6 months or so getting there. And after it lands, which is a retro rocket land, it's going to come in, you know, barreling in, and it has a heat shield, and so it's going to go through the Martian atmosphere and transfer a lot of that kinetic energy into thermal energy, right? So it's going uh, go through the atmosphere of Mars, heat up. They've got a heat shield on the front. When when that's sort of used up, and they're going, I think like I don't remember, not incredibly fast. Then they drop that and they deploy um, some parachutes, and the parachutes slow them down even more. And when they get to a certain height above the surface of Mars, um, the parachutes release and the lander drops. It literally just drops. Um, but retro rockets fire, hopefully, and it does a nice soft landing on the surface. I think the final velocity when it hits the surface is like 5 miles an hour, something like that. So it's pretty exciting. It's always hard to land those kinds of things. You really never know exactly how to do it. Spirit and Opportunity, they uh, encase themselves in in like these big balls, and then when they dropped, they sort of bounced, and then they deflated these balloons or balls, and the, uh, the the landers were in the shape of a tetrahedron. So regardless of what their orientation was, they could always right themselves. And then, you know, they did their thing. But Mars InSight has I guess 3 main experiments. The first is a seismometer, a very, very sensitive seismometer. They really don't know what's causing these little landslides on the edges of craters. So they're trying to figure out what's causing those. And they also want to be listening for meteor strikes, which they've also observed. Probably due to the sensitivity of this thing, they'll also be able to hear um, the supposed dust devils uh, that are pretty frequent on Mars too. So yeah, very, very cool. And they've got a drill rig that they're going to try to drill 15 meters down into the crust, you know, the very, very shallow crust of Mars. And they think that 15 meters is enough to sort of let them extrapolate a little bit and and um, and try to understand the temperature profile of Mars as it goes from the center out. So yeah, that's a little bit of a stretch. 15 meters, you know, is not very far, but you know, they can plug this data into their models and you know, see what happens there. See what happens. And then they have they're going to use their uh, radio communications devices on the lander to measure the wobble of Mars's axis. So you know it's rotating like this, but just like a top, it probably has a precession, but it also has, you know, these wobbles, and I guess they're pretty high frequency wobbles. You know, not incredibly high amplitude, right? But pretty high frequency. I guess they're at least from, you know, the briefing I saw, they're expecting to see like daily wobbling. So interesting, very interesting. So launch this morning at 11:05 UTC, and locally here, I'm in southeastern Arizona, United States. That was 4:05 a.m. So I got up about 3:30 or so and went up on the roof of my house with my smartphone in hand. Is it 5 meters or is it 15 meters? I guess you're right, Tom. Yeah. 5 meters sounds maybe a little bit more reasonable. So, yeah, confusing units again. Yeah, I think you're right. I think you're exactly right. 5 meters, 16 feet. Yeah. Um, so so watched the launch and was hoping to maybe see something. I was sort of hoping to see maybe the second stage firing, um, or maybe it was getting high enough that it would catch a piece of the sun. But nope. I looked and looked carefully. I even I watched um, um, very, very carefully. Also, you know, taking into account that, you know, probably the delay of the live stream was something like, you know, 20 seconds or so, um, something like that. Still did not see a single thing. Now, I think that I'm going to go and get a fresh batch of hydrogen hydroxide. So I'm going to be back in like a minute. So hang there. No anarchy. Um, But I will be right back because, yeah, I need some fluids. All right, I'll be right back. All right, woo, much better. Thank you for that. Yes, I am. I am very, very far from Vandenberg, Tom. However, however, um, you remember a couple of months ago when SpaceX launched from Vandenberg, and there was a lot of excitement because it was seen at Disneyland and all that. Well, supposedly, the story that I heard is that that plume was seen from a location very, very near me here. And, I was like, arr, arr, didn't even think of that. Didn't even think of that at all. So now, now every single time there's a Vandenberg launch and it's heading south, right? If it's heading south, I am definitely going to, as long as I'm in a position to be able to see it, I'm going to take that chance. Now, if it's a daylight launch, I'm not going to see it, right? If it's a sunrise or sunset launch, yeah, I would think that there's a pretty good chance. If it's a nighttime launch, like what it was today, um, very, very, very unlikely. As I said, I was sort of hoping to be able to see, um, uh, either the second stage Centaur ignite and go, um, or um, um, uh, or see some kind of plume or trail. But I saw nothing. I saw nothing. I saw nothing moving. I saw no vapor trails at all. So I've also got a mountain range that is very, very low on the horizon. It's probably no more than 5 degrees um, um, above the horizon, but that's enough. That's enough to actually block the horizon pretty well. So yeah, and it could be atmospheric. Who knows? Who knows? But nope, I didn't see it. Oh well, no big deal. Probably see it at some point. Cheers. Yeah, Uncle Bill, I think I saw that video. They were actually sort of above it, and they, at least the picture I saw, was the rocket going through the clouds. Is that right? I don't know how they can get away with that. I'm not sure. I didn't see it very, very well. I didn't look too closely either. So yeah, yeah. But I'm not quite sure how private planes can be getting that close. I mean, they want to have a pretty good radius, I would think, of safety uh, around that. I would think it would be uh, quite a ways away. So yeah, maybe it was zoomed in. Yeah, I don't know. I don't know, but apparently, and I watched it through to deployment, and the spacecraft was successfully deployed, And so it is on its way, along with Marco A and Marco 2 CubeSats that are going to be going to Mars as well. Now, of course, that Centaur B is also going to Mars, but it's it's on a different path. So it's not going to interfere or anything with the spacecraft. So very, very cool, very exciting. This is I guess, sort of a sort of a classical Hohmann transfer orbit. It's like a 6-month trip. They're going to be there in November, and they're going to land. And it was kind of funny, they one of the people they were talking to this morning said they have like 35 opportunities to launch and 1 opportunity to land. so yeah, that's absolutely true. It's absolutely true. So it's always a hair-raising event, these landings, because not only is it just because it's the landing itself, but also because you know in your head that it's delayed. It's delayed by 15 minutes, something like that. It's maybe not that long, um, but so the only thing that we can do is watch, right? So we're receiving signals from Mars um, in real time, but that's our real time. It's when that information actually gets to us. But that information, those events are happening um, in our future, right? So there's a delay. There's a delay, and or in our past. In our past. Anyway, things happen at Mars. That information is transferred. It takes a certain amount of time for the light, the radio light, to travel that distance, and by the time it gets to us, the event is over. So so behind the launch azimuth, the no-fly zone is actually quite close. Wow. Okay. Okay. Yeah. Interesting. Interesting. I would think that it would be pretty far, but yeah. Um, I mean, hopefully they've worked all this out, so they would know. I definitely don't have a clue. So yeah. But anyway, so it is on its way. It's going to get there in November. Hopefully, it's a good landing. They're landing in a very boring, quiet spot. Nothing really to see. I think there are cameras on it. I'm not exactly sure. I don't know why this camera's acting a little weird tonight. I don't know. Um, But yeah, I don't know if there are any cameras on it or not. I would think that there would be some kind of camera, maybe not high res or wide field or anything like that, but some kind of camera. Um, but yeah, then they're going to deploy the seismometer with this arm, right? It's like a Canada arm, right? It's going to grab the seismometer off the spacecraft and lift it up onto the ground, just kind of like that. And then it's going to do the same thing with the drill, right? It's going to grab the drill and plop that on the ground. So yeah, I figured InSight probably does have cameras. Does it have like high res cameras, or are they like navigation cameras? Um, uh, sort of not low res, but more like an engineering camera, as opposed to like a panorama camera. Um, yeah, it's always nice to have cameras because that helps us humans get like instant information, right? That way. So very cool. Cheers. So yeah, I was started a couple of minutes late because, as I said, I was watching Gilles' shortwave radio show earlier, and as I said, he's really great. Shouts me out, and he starts talking astronomy, and every single time he does that, I'm reminded that there's a really cool thing that I want to get into. Um, okay, with 120-degree wide angle. Okay, all right. Well, cool. Then we're gonna get some interesting shots from probably apparently a pretty boring place. I wonder if it's gonna be as boring as Viking. So I don't know. I don't know. But there are two big problems that optical astronomers have when it comes to making observations and getting the data that they want. The two big problems are daylight and clouds. Daylight and clouds. Um, that, daylight makes it such that optical astronomers can only collect their data uh, when there is no daylight during the night, right? When the sky is transparent, there isn't all this scattering, um, this Rayleigh scattering from mainly the nitrogen in the air. The sunlight comes in, and most of it just sort of goes straight through, but some of it gets scattered, and that scattering is our blue sky. Our sky um, during the day becomes opaque, and we can't see through it, at least in the optical. And then of course clouds, right? Clouds are the bane of the optical astronomer, and I have yet to see a cloud filter uh, um, in the optical. So yeah, let's see. Both are color. Both cameras are color. A lot to see in a safe landing zone. Yeah. They're InSight is there for a completely different purpose. It really isn't necessarily just geology and surface things, right? They want to look inside, and yeah, seismology is the way to do that. It's amazing. It is absolutely amazing what you can learn from uh, you know listening to and measuring vibrating things. They do um, helioseismology as well. They actually look at the light from the sun, and they can see it, vibrating, and so you can get an idea, at least they think, of what the interior of the sun uh, is doing. And regular seismology is like that too. You can, measure the vibrations on the Earth or on Mars or on the Moon, wherever, and you get a profile of how those vibrations have moved through all of that material. and there are reflections, and there's scattering, and there's actually refraction too. So the high frequency signals actually move faster than the low frequency signals. So it's actually, it's the same kind of thing as in optics. There's refraction, there's diffraction, there's reflection, scattering, all of that. It's just it's more sonic, right? It's more um, uh, uh, yeah, it has to do with sound waves as opposed to light waves. But apparently, waves are waves. So, all right, enough about Mars. Mars is very, very cool. Um, so, yeah, the optical astronomer uh, is limited by daylight and clouds. But there's another kind of astronomer who doesn't have those kinds of limitations, and that is the radio astronomer. Um, in radio wavelengths, the sky is always opaque, even with clouds. Even with clouds, um, the clouds just aren't there, right? They just don't even show up. The only thing that you have to worry about is, well, you know, in terms of large scale things, the only thing that you really have to worry about and try to generally avoid is the sun, because it's very, very bright. It's very, very bright, not only in optical, but at all wavelengths. So ultraviolet, it's extremely bright. In the optical um, or visible, it's extremely bright. Uh, um, uh, in the radio, it's extremely bright. So if you've got a radio telescope that you've got the gain turned up to 11, right? You've got this thing cranked, right? You don't necessarily want to be looking at the sun, because you're trying to look at, you know, a quasar, or some extremely distant source that is very, very faint, right? Low signal is very, very faint. Um, so you've got this thing cranked, right? You've got your amplifier cranked, to 11. You've got your receiver, very, very finely tuned, um, and you don't want to be looking at any bright sources. Um, but the cool thing is that you know uh, little people like me and you can actually set up a radio telescope, and observe, make measurements of not only the sun, but you can look at the Milky Way, the galactic center and the galactic disk, and you can look at Jupiter, and you can actually observe and record events, electrical events going on at all three of those places. You can see in quotes, um, solar flares and solar activity of all sorts. Same with the galactic disk, and same with Jupiter. And one of the things that I want to do, I'm on a I'm on 10 acres. That's pretty much just a perfect square. So I've got from corner to corner, I've got a little over like 400 feet or so. And 400 feet would make a really, really, really large baseline for a radio um, interferometer. And um, with an interferometer, you can actually do high resolution um, um, imaging, and depending on how much, you know, uh, how big your light bucket is, how large your antenna is in this case. Um, you might be able to see some pretty faint sources, um, and actually be able to do some high resolution um, imaging of those faint sources, or of the sun, or Jupiter, or the galactic disk. So I've been wanting to do this for a long time, and pretty much every time I'm watching Gilles' shortwave show, and he starts talking about astronomy, I start to think about radio astronomy, and how much I want to get into that, and that always reminds me of a site that I found um, several years ago called Radio JOVE. Radio JOVE, and these are this is a site. I think I froze my Linux machine. Because I let this thing go too long. If I, oh man, I'm in big trouble. The mouse is still working, but the rest of the machine is frozen. Oh, I let this go too long. Oh no. For some reason, if I watch a live stream on my Linux machine, it freezes. It completely freezes. Now, I'm going to try to save it, but I don't think there's a chance. It's been running for a good 30 minutes now, so I don't think there's a chance. I don't think there's a chance I can save it. Maybe I can kill my browser. I might be able to close tabs. I might be able to. Come on. Oh, there we go. Yes, I have angry bits, but I think I saved it. Somehow, I think I saved it. Let me come over here and look at the processes -D 0.1. Oh, it's still running really, really slow. It's still, just because the browser goes away, it usually takes a few minutes to actually kill the whole thing. Yeah, so it's still running in the background, but I think I saved it. Yay! So anyway, I think of this site called Radio Jove, and I posted some links in my Discord server. You can find a link to the server down in the description below. But yeah, I just wanted to. I do not know anything. I know very, 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 very little about radio astronomy, but I want to learn more because I really want to get into it. I will always be a optical astronomer for sure, but it's frustrating that I have to wait till it gets dark, and it's frustrating when it's cloudy, because it's like, oh, it's just stupid, right? But with a radio telescope, I can pretty much observe whenever I want. If my target is up, right above the horizon, I can see it. Turn off my fan there. Um, So yeah, let's just go over to Radio Jove and poke around. I'll show you some things that I've found, and we can just sort of spend the rest of the time just sort of surfing around um, um, Radio Jove. And uh, as I said, this live stream is not educational. I'm not trying to teach you things. I'm not trying to, do any kind of lecture. What I'm trying to do is share a common passion. So we go on these things together. Um, and as I said, I know almost nothing about radio astronomy, but I want to learn more because I would absolutely love to build, um, as I said, a radio interferometer here on my property, and be able to do some serious radio astronomy, scientifically valid radio astronomy, and I think I can. I think I can. I don't see why I can't. So I'm going to share my screen, and we'll go over to. So here's the my. I'm not able to monitor my. Um, uh, yeah. Well, look, Uncle Bill, try to run a YouTube live stream. Just watch a YouTube live stream on your Linux machine. I'm running Firefox, so maybe that has something to do with it. Don't know, but yeah. In fact, I'm looking at my processes now, and the the browser. Oh, it's probably still running because I've got the chat up. So I'm going to kill the chat here really quick. So I'm not going to see the chat for a couple minutes because yeah, there it goes. Because I want Firefox to completely shut down, and then I'll restart it. There it goes. Okay. Yeah, because it was the, okay, so I'm going to restart Firefox and pull the chat back up. By the way, I also posted a picture that I took this morning of the moon almost exactly between Mars and Saturn this morning. That was actually the highlight uh, of the whole uh, thing this morning was being lucky enough to be at the right place at the right time to see that, because that was very, very cool. So I posted a picture of that, um, also all over on my Discord server. I don't remember exactly what channel I posted it to. Maybe miscellaneous. Is that where I did it? Miscellaneous. Miscellaneous. So that's a 10-second exposure. So the moon is like extremely overexposed. It's got these beams coming out of it. Those are all optical effects, internal reflections and whatnot. But on either side, almost exactly symmetric, is Mars on one side and Saturn on the other. So I was in the right place at the right time, and I had the camera, and it's like, wow, that's a very cool shot. So yeah, there you go. You can also see. I guess you're probably looking at this. Let's. Yeah, because Yeah, I forgot that I was sharing my screen. So yeah, you can sort of see what I was seeing. So there's the moon, right, with these big beams coming out of it, and there's Saturn, and there's Mars. I think if I zoom in, yeah, that's a little bit too much, but there's Saturn, there's Mars, there's the moon. So yeah, really, really close. You can see the tail of the scorpion here, and you can see Sagittarius, right? Here's Sagittarius. So the center of the galaxy is, right about there somewhere. Um, so yeah, very, very cool. Very, very cool. Nice little alignment there. All right, enough distractions. Let's do some radio astronomy. So here's the Radio Jove site. Now the one thing about the Radio Jove site, the, most of this site is very, very, very uh, old, outdated. They haven't updated a lot of pages, but stuff like this, right, is pretty up to date, pretty pretty up to date. So let's see, I found a paper, yeah, about the Radio Jove project. So let's just look at that really, really quick. So they actually have a kit, right, where you can buy the the antenna, the receiver, the whole thing. You just have to set it up, right? Just have to set it up. Costs a couple $100. Um, and some software, and that's it. That's showing countries who are participating in it. It's pretty much the whole world. They've covered most of the world. There's nobody in Russia apparently that we're looking at it. But there's the receiver. Here's the antenna. So they're using some kind of interferometer as well, right? Because there's two antennas here. There's a north and a south. Hey there, Jill. Hey, your live stream always reminds me about how much I want to get into radio astronomy and do um, interferometry, and that always reminds me of this site. It's called Radio Jove, and they are um, uh, looking at sort of three sources. They're looking at the galactic disk, the Milky Way. They're looking at the sun, and they're looking at Jupiter. And I'll show you some data here in a little while, but we're just sort of going through this. I really want to get into radio astronomy, and unfortunately, I know almost zero. Um, but this looks like a interferometer to me, right? There's um, two antennas here that are separated by a certain amount of distance, and yeah, here's some data. I'll show you some more though. This really isn't what I want to show. This is just a paper that was written back in 2014, just sort of uh, um, describing the setup and stuff. So yeah, they're centering on around like 20 megahertz or so, um, and so yeah, as I said, I have to get into this because I'm just barely understanding what's going on here. But there's a receiver, there's a spectrograph, right, and they can actually uh, you know take a spectrum of data, and this is actually what they get, right? So this is time, this is UT time over here, and then these are frequencies in megahertz, right? So this is going from about 16 to 32 megs, and apparently this stuff here, these little like cloudy things, um, uh, uh, are radio emissions from Jupiter, specifically these things that they're calling EOA emissions, which is some kind of an interaction between Io and Jupiter. And I I have I have I don't have a clue how to interpret these at all, except they look very, very broadband, right? They're going from, you know, 20 to 30 at least here, right? Very, very broadband, very complicated, very, very, very dynamic, right? Very, very dynamic. It looks like I don't know if this is like some kind of Doppler thing. Um, I just don't know. But, they're all, and I see this a lot. I'll show you more data here, where, these angles always seem to be about the same. So yeah, I'm not understanding what I'm seeing yet. There's some more of the same thing. These, I think, are solar flares. So happening at a particular time, and being pretty broadband as well. Yeah, some solar bursts they're calling it. So this is like a 1 minute window. Looks like more like a 10-minute window, but whatever. Okay, yeah, yeah. I'm gonna have to get into this and understand it a little bit more, which probably means I just need to build a receiver and you know see what happens. So this is the archive, and this is when it gets kind of cool, um, because this archive is available, right? We can actually go to it and check out the latest observations. But before we do that, let's just look at this as well. This is what they're calling the Jovian decametric radio emission. So apparently, um, radio bursts from Jupiter were actually, I guess, accidentally discovered. So and so yeah, I guess I'm not going to go through this too much, but I know that Jupiter has many, many moons. Could they affect radio waves? It turns out that Io has a very big effect on whether we hear any radio emission or see any radio emission from Jupiter or not. It was a large moon, about the size of our own moon, but it's still small compared to the enormous planet Jupiter. Io is very unique since it is the most volcanically active body. Io is continuously flexed by the gravitational pulls, blah, 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 blah. So tons of material are ejected from the surface of Io, and some of that gets ejected into space and is ionized, trapped within Jupiter's magnetic field, and this creates this big donut-shaped torus around um, Jupiter. And I guess it says here that Io enhances um, Jupiter's emission of decameter radio waves, which to me sort of is like 10 meter, 20 meter, 30 meter. Don't exactly know what decameter means in this context. Um, so yeah, it's just it's the interaction of the spinning of the planet with the orbit of the moon, and so you get uh, these emission probabilities that I just totally don't understand at at all, right? Not at all. But apparently they happen um, regularly and can be observed. And yeah, this is the kind of stuff that I'd like to get into because I want to understand what what exactly I'm measuring here. I'm not exactly sure, but I think it's very cool. Let's see. So we can look at the galactic background, sort of the same idea. That's not very exciting. All right, well, let's look at some actual data. So we can go over to the data archive, and you can go over to view calendar, and you can actually see this is an up-to-date calendar. Um, People just submit their data to this uh, archive, and it's completely accessible, you know, to anybody who wants it. And I've noticed that pretty regularly, you know, there'll be um, galactic measurements, but not too often. Maybe once a week or once a month, there'll be observations of Jupiter or the Sun. Um, uh, yeah, yeah. Take a look because um, apparently, yeah, like 20 megahertz, 21, 22 megs is where it emits, and I have absolutely no idea what the mechanism there is. I don't know why it would be 22 and not 2. Don't have a clue. So, but yeah, yeah, I think take a look, I guess, and see if you can, you know, pick out Jupiter from, you know, the rest of the noise. I don't know. I don't know. But anyway, let's look at the galactic background, right? So you're going to see emission from the galaxy basically twice a day, right? When it's going over your receiver, right? The galactic disk. Since we're sort of embedded inside of the galactic disk, we're going to see it twice a day. Once while we're looking in towards the center um, of the galaxy, and then again when we're looking out towards the edge of the galaxy. Uh, and so that's what this stuff is showing. It looks like this particular guy, right, made this observation on April 4th. It's today. Um, and he did it for an entire day, right? 24 hours. He started at 0 hours and went to 2359 at a frequency of 20.1 megahertz. And this is what he got. This is what he got. So this is the time, right? This is the universal time. And this is something that maybe you radio guys can answer for me. If you look on the edge here, this says antenna temperature degrees K times 1,000. So are you telling me that these measurements here are exceeding 250,000 degrees Kelvin? I'm not sure how I'm supposed to be interpreting this. But there's a lot of pops. There's a lot of pops. There's a lot of interesting structure here. See how this jumped, suddenly jumped, and then there's this smooth stuff, and there's some structure in here, and yeah, it's just, that's kind of a messy one. Let's look at another one that maybe is a little less messy. Let's see. Yeah, okay, so here's a perfect example, right? Where you've got your radio antenna stationary, but the Earth is rotating. So you're going to see the galactic disk here and here, and then also here, about 12 hours apart, right? Depending on, you know, your latitude and all of that. But look, there's this thing too, and again, you know, there's this structure here. Very interesting, very interesting. But yeah, this this temperature thing is driving me crazy. That's antenna temperature degrees K times 1,000. So, you know, that's like 50,000 degrees Kelvin. No, there's something wrong there. There's something wrong. I'm not quite sure what that means. Not quite sure. But this is radio emission, apparently, from the um, Milky Way, you know, the galactic disk. So that's very cool. And so, yeah, that's what a lot of this is. Let's look. This is the current month, right? So this is May 2018. Let's go back to April 2018. And you can see that not only is there galactic background measurements. Thank you, Larry Dodd. Thank you. Same kind of thing, right? Same kind of thing, same, but yeah, lots. Oh man, there's lots of information here. Lots of information. Um, yeah, you know, um, 20 megahertz. Um, is 20 megahertz in sort of the amateur band? Sorry, I'm embarrassed, you know, to say I don't know. But let's look at Jupiter. So here's one kind of plot that we'll see from time to time. So this is the universal time down here. Look, it's going from 5:10 UTC to 5:20 UTC. So this is a 10-minute interval, and it looks like it's going from about 16 megahertz to about 23 megahertz. So this is time along this axis, and this is frequency. So it's a lot like it's a lot like a sideways waterfall, right? Same kind of thing. Any of you SDR guys are going to recognize this. So you know, here's a little thing of some sort going through there. Now, I'm not sure if these bands are you know, are like local radio bands, if they're part of the background. I'm not exactly sure what these bands are for, but apparently these like cloudy things here, which get pretty intense, right? Pretty intense. You see this weird angle here? This weird angle. Anyway, yeah. Apparently, this is all emission from Jupiter. Apparently. So let's just look at some other ones, some other Jupiter ones here. Jupiter. Okay, so here's a guy who has submitted some data from this IOC type storm and IOA type storm. So let's just look and see, all on the same date, not at the same time, but yeah, let's just look here and see. So okay, so this is just time versus intensity, right? So he's got this thing tuned to 20.1 megahertz. And this is just like a strip chart, right? So it's showing time versus some kind of an intensity. I don't know what the values are here. They might sort of be arbitrary. Don't know if these numbers are actually physical, or if they're just sort of, analog um, um, analog to digital units. But you can see that apparently there was some activity here and maybe here. Let's look and see what else he's got. This is a little bit beforehand. Same kind of thing. Not much activity. A little bit. Whoop, went too far. Let's look at this one. There again is some activity of some sort. Jupiter, I guess. I don't know. I don't know enough about this. I'm on a learning curve. So there's some more of the same. And then Larry Dodd. Let's see what Larry Dodd did. It looks like he's got a spectrum, more like a spectrum. Ooh, that's very cool. See, but you see how I think these angles are significant in some way. But this, again, this is like 2 minutes of data, right? 636 to 638. Okay, so they're seeing auroras over Europe and northern parts of Canada tonight. Yeah, it's that big coronal hole that's spewing out protons. Yeah, very cool. Anyway, so yeah, I'd like to understand this a little bit more, because wow, there's so much structure here, right? And as I said, I don't know if these bands are like background um, or not, but this, these are very interesting, right? Don't know what's going on there. Don't have a clue. Want to know more. Let's look at some more Jupiter things. So here's from April 2nd. More Jupiter stuff. Jim Brown. So some little pops. And again, these antenna temperature is just insane, right? 226,000 degrees Kelvin. That just doesn't make any sense to me. Let's look at Larry Dodd's spectrum. Probably a spectrum. Huh, kind of interesting. Little, I guess you'd call these um, um, Jupiter events. Don't know why they look so different than the other ones. I always have questions. So let's see if there's a sun one. I'm sure there's a sun one. Yeah. Okay. So here's a sun observation. And I think all of these are just sort of the strip chart type of things. Yeah. So you can sort of see that some kind of either a solar event, probably a solar event, because I'm looking at the UT time here, and that's pretty short, right? This is like 1 minute apart. So yeah, these are some kind of flares that are going off on the sun, apparently. Let's see what this shows. Okay, this shows a lot. Okay, very cool. I guess some more flares. Look at that structure. Isn't that amazing? Nothing is simple. Who would want it simple anyway? There's a lot of information in that. Let's see. Okay, so here's a longer timeline. This is this is like 45 minutes worth of data. So you can see that's happening about 18 hours UTC. Let's see if that's yeah, see, so that's what that is. So yeah, cool. Let's see if there's any more spectrograph. I don't know what this is. Okay. Okay, so it's showing the same events at 1800, and then these things going on. So yeah, I don't know if these are all solar events, if this is the sun and this is Jupiter. I just don't have a clue. I don't know. Let's see. Here's another Jupiter one from what, March 23rd. So there we go. Pretty interesting. So yeah, I really want to get into radio astronomy because I think it'll satisfy my urge to do astronomy and also do it whenever I want to. So this is the Alakua spectrograph. I don't know. Hmm. Okay. Interesting. Don't know what it means. What does it mean? What does it mean? I don't know, but it's very cool. Here's interference. I don't know what interference is. Oh, okay, so that's just a file type. So I don't don't have any pictures there. Yeah, it's another way of viewing the universe. See, Jill, that's the thing, and that's one of the purposes of me doing this live stream too, is that I want to offer different perspectives because definitely when you do astronomy, every single time you look at something differently, it's like a completely new thing. And so when you look at a galaxy in the radio, it, it, it has certain characteristics. And when you look at exactly the same galaxy in the visible or the ultraviolet or the X ray, any of those, there's just, it's like a completely new thing, and that gives you a broader perspective. And my thing is broad perspective. Let's not you know um, narrow ourselves down to one thing. Let's look at it every single way that we possibly can. So yeah, it's just it allows us to see things um, in new and different ways, and I think that's awesome. So these are all storm types EOA. I'm still trying to understand what that exactly is. It's some kind of geometry. It's some kind of an alignment. Not quite sure exactly what that is yet, but yeah, let's just look here. So that's a strip chart again. Okay, these are these are probably all strip charts then. Maybe not. Different observers. Let's see what Jim Brown brought to the table here. Okay, interesting. Wow, there's a big a big spike there. Has been fascinated by radio monitoring of pulsars. Yeah, yeah. Well, they're talking about actually using pulsars for spacecraft, use them as GPS type beacons, because their timing is so precise that they can actually use them as positional beacons. And so spacecraft that are going to Mars or going to Jupiter or going to Pluto or anything like that, um, they'll be able to use apparently pulsars uh, to figure out their positions. There is an experiment on the space station right now that is collecting that data, and so yeah, it's going to be interesting. It's going to be interesting for sure. Anyway, there was a big spike there, a big radio emission of some sort. Don't know if it's coming from Jupiter, if it's coming from, yeah, I just don't know. Let's see, Jonathan Trow. Okay, not very much activity there. Let's see what Jim Brown, Hawk's Nest Radio Astronomy Observatory. What a cool name. Hawk's Nest. Ah, lots of activity there. Very cool. Apparently this is Jupiter activity, right? Some kind of EO Jupiter interaction going on. Let's look at one more, and then I will let you all go for tonight. I was just thinking about this after Gilles' show, and I got on to Radio JOVE, and I spent the last hour or two, just looking at all this as well. It's like, well, okay, I'm just going to keep looking at it and just do it live. So yeah, again, apparently this is radio emission from Jupiter. Lots of structure, lots of um, uh, yeah, pulsing and yeah. I wish I understood it more. I'm gonna try to understand it a little bit more. So apparently, this is probably the same pulsing, right? 1006. 1006. Let's see. Whoop. 1006. 1006. Yeah. So yeah, it's just it's the same thing as this, just looking at it in a different way, doing a waterfall instead of a strip chart. All right, well, cool. I think yeah, as I said, what I want to do, I've got a 10-acre property here, and I can make a radio interferometer with a baseline of like 400 feet or so. And so I've been wanting to do that for pretty much as long as we've been here. And yeah, I just it's a little bit of this that is needed, and a lot of know-how, a lot of understanding. But fundamentally, it is just a telescope, just like that. It just operates in a different way. The dimensions are more physical, as opposed to, the dimensions here are, measured in angstroms, right? Where dimensions for radioscopes, are measured in meters. So it's just a different scale. But yeah, lots of different things can be done. I definitely would like to get into radio astronomy, so I doubt daylight, and I don't have to worry about clouds. I think that would be very, very cool. So yeah, I need to move in that direction. All right, speaking of moving in directions, I think I'm going to get out of here for today. Glad you could come in. I like to keep this to about an hour. If it goes a little bit long, that's all right. But I'm doing this every single day, so I don't feel as though I have to have a long thing or try to pack a lot into a short amount of time, because my observation so far has been that tomorrow does arrive. Tomorrow will come, And so probably, most likely, I'll be doing this again tomorrow. Same time, same place. It's been clear. It's clear again tonight. It's a beautiful, beautiful, dark, dark, dark night, and I'm not out there. But I'm thinking that maybe tomorrow night I'm going to get out again and get some more binary star data so I can check this system out. I need to figure out what's going on with it, at least parameterize it so I know what I'm working with. And I'm trying to understand why photometrically I'm not getting the accuracy that I sort of expect. So yeah, all right, yeah, hit the thumbs up, do it, do it. Your Uncle Bill says hit the thumbs up. You know, if you don't like this, hit the thumbs down. I like a reaction, so that's fine. That's fine. Make sure to share this around for sure. And if you're watching this for the first time, make sure to subscribe. Hit the notifications, and you will be informed, apparently, when I go live. But it's every day, 2 hours UTC. All right, I'm going to get out of here for now. Thanks for stopping in again. This circle of friends sharing a common passion. All right, take care, everybody. I will see you. I will see you on the spin. All right, bye bye.